Don't forget to subscribe and ring that bell.
Heidi ho there, neighborinos. Welcome back for some of you that may have seen other videos of mine, and welcome to those of you that are first-timers. We are going to start the 2018 practice exam that College Board put out for AP Calculus AB, starting with multiple choice question number 1, and this video will end with multiple choice question number 10. Meh, who cares if we don't get a calculator? We're good. We're good. We kill math. That's what we do. Okay? Section 1, Part A, we're going to begin. Follow me. That's how you get notifications when I put up new videos, like the ones that will follow this first one for this test. All right? Like the video, that helps me. And if you want to see a test that I don't have up, I have a handful of them up now. If you want to see one that I don't have up, shoot it in the comments, and I will indeed do it. Let's start. Number 1 reads, if f is the function given by f of x equals 4 over x plus 5x minus 1, then find f prime of 2. All right, well, you got to know at this point of the game that you need to take the derivative of f and then plug a 2 in for your x value. All right, I'm going to alter this a little bit. I'm going to bring this x up and call that 4x to the negative 1 plus 5x minus 1. I have not taken the derivative yet. I've just rewritten that, so it's easy. The derivative of the first term, I multiply negative 1 times 4. That's negative 4x. And I subtract 1 here, make it negative 2. Plus the derivative of 5x is 5. Minus the derivative of 1 is 0. This can go bye-bye. So bye-bye. Let's now switch this back so that my exponent is positive. So I'm going to bring that down. Okay, this is the derivative we have. And now before I put in my x value, I'm just going to rewrite it. Negative 4 over x squared plus 5. I want this at an x value of 2. So let's plug in that 2. Negative 4 over 2 for my x squared plus 5. Well, I get negative 4 over 4 plus 5, which is negative 1 plus 5. Oh, my God, look at all those 4s. Look at all those 4s. A, 4. Number 2, integrate e to the 3x dx. All right, well, I mean, that's fine. That's fine. All right, first thing I'm going to do is I'm going to take this 6 as a constant and move it out here. Okay, this is classic U substitution. Some of you might have done problems like this long enough that you see a pattern and you don't have to do the U substitution, and that's cool. But we're still going to go and show the U substitution just for extra practice, okay? I'm going to make my U 3x. So it's e to the U I'm going to integrate. I still have the 6 on the outside. All right, so du is going to be 3dx. Well, I only have a dx left. This is already bye-bye substituted. I don't have a 3. So what I want to do is get rid of that and multiply both sides by a third. So this 3 and this 1/3 cancel. Now, in for dx is du and my 1/3. So that's a constant. I'm going to put that out front. That's multiplication. All right? So now let's integrate this. The integration of e to the u is e to the u. All right? 1/3 times 6 is 2. And then don't forget, there are no bounds, so I need to do a plus c. And the last thing I need to do is, because there are no bounds, I need to take my expression. Whatever u was needs to go back in. It's 3x. So it's 2 e to the 3x plus c. And that, my friends, hey, twice in a row we had choice A as the answer. There you go. Number 3, the graph of y equals f of x is shown above. Oh, I love graphs and charts and tables. Anyways, What is the limit as x approaches 1 of f of x? All right. Well, I'm going to draw a vertical line where x is 1. Okay. This is the line where x equals 1. If I want to find the limit graphically, which is the easiest way to do it, I just follow from the right side to x equals 1 and the left side from x equals 1. Okay? So let's start with the right. Yeah. Kids. This is the left side. This is the right side. Good morning. Have some coffee. Now, as I approach from the left, closer to that line, x equals 1, I approach a y value of 3. All right? And as I approach from the right side, okay, I get a y value of 1. Okay, those have to be the same number for the limit to exist. Since they are not the same number, the limit does not exist. And in terms of notation, my goodness, the limit, you know what? That's just poopy writing. Oh, Lord. The limit as x approaches 1 from the right side does not equal the limit as x approaches 1 from the left side. These need to be equal in order for the limit to exist, and they don't here. Choice D. Number 4 reads, if f prime of x equals 3x squared plus 2x, and f of 2 is 3, then what is f of 1? All right. First of all, so many things here they're testing you on. By so many, I mean really 2. Let's go orange, because it's still November. We haven't hit Thanksgiving yet. That's a nice color. Right. The fundamental theorem of calculus, I think part 2 of it, is if I integrate a derivative with some bounds, that is the original equation with the bounds plugged in, the difference of them. Okay? That is just a basic idea of integrals for calculus. They give us a derivative, and then they give us values, okay, for the original equation. All right? We can say this is f of b, and upper limit is 2. And f of a, the lower limit is 1. So really what I can do is I can say I'm going to integrate f, well, let's call it 3x squared. Go back to our orange, because that was pleasant. I'm going to integrate 3x squared plus 2x dx. That's going to equal, okay, if I do that from 2 to 1, that's going to equal f of 2 minus f of 1, okay? They give us f of 2. That's equal to 3 minus, and this is what we're solving, f of 1. All right, so all we got to basically do is do the math here, okay? And it's really not that difficult because this is a non-calculator problem, and it's one of the earlier problems, problem number 4. All right, so let's integrate this here. We're going to have x cubed plus x squared. I want that from 2 to 1, and that's going to equal 3 minus f of 1. All right? Let's get some room over here. Let's do this over here now. So I'm going to put my upper bound in. 2 is going to go in for these x's. So it's 2 cubed plus 2 squared. That's the upper bound. Minus putting in the lower bound of 1 for these x's now. 1 cubed plus 1 squared. And that should equal 3 minus f of 1. All right. 8 plus 4 is 12 minus 1 plus 1, which is 2. So this is going to be 10 on this side. 10, let's bring it back over here for the sake of seeing everything on one screen. 10 equals 3 minus f of 1. I can do some algebra. I can realize that that should be negative 7. But let's do some algebra. I subtract 3 from both sides. Ooh, there's a negative 10. There should be 10. What did you get? Negative 7. What? Yeah, 7. You got nervous there for a second. And then I'm going to multiply both sides by negative 1. The negative goes away. I multiply this times negative 1, and I get negative 7 equals f of 1. There you go. All right? So that one really, B. You need to understand this. This is a given. This was easy to do. They give us this, and here's our unknown. All right? Choice B, negative 7. Number 5, a table. Love it. During an evacuation drill, people leave a building at a rate of RT. So this is a rate that they give us, okay? And I like this bright green. People per minute, where T is the number of minutes since the start of the drill. Selected values of R of T are shown in the table above. Using a right Riemann sum, that basically means RAM. With 3 subintervals and data from the table, what is the approximation of the number of people who leave the building during the first 15 minutes of the evacuation drill? I am basically doing RAM to this table. Okay, so these are already equal subintervals, okay? They want 3 subintervals. There's the first one. Here's the second one. Yep, blue. Here's the second one from 5 to 10. Okay, and here's the third one from 10 to 15. Notice they are all a width of 5 minutes. So these widths are 5. These widths are 5, and the width is 5. That's good. So I don't got to break it up into different, calculations or whatever because they're different widths. They're all the same widths. So subinterval 1, subinterval 2, subinterval 3. And the way I do this is I got to add up, okay, all my y values, and multiply it by the width. The width happens to be 5. 5 times. Now I'm going to have 3 values. Okay, and remember, it is a right Riemann sum. So when I look at subinterval 1, I have 2 values here and here. I'm going to use the right one. That's 100. Okay. Then I look at my subinterval 2, and I got 2 values. The right one is 75. And then I look at my third subinterval, and I have 2 values here, but the right one is 55. Okay, let's add these. It's 120, 130, 230. So I got 5 times 230. And don't cry about this because we don't get a calculator. This is basic math. 0, 15, carry the 1, 1150. Wouldn't that have been embarrassing if after I said this was basic math, I got that wrong? Well, I think it was more embarrassing that I flipped and flopped the left and right in the other problem. If I couldn't tell my left and right apart, it would have been difficult to do this right rectangular approximation method or Riemann sum. Choice B. 6. If y equals x squared times e to the x minus 1, then dy dx is basic product rule. Basic product rule. The first times the derivative of the second plus the second times the derivative of the first. So it is the first times the derivative of the second. The derivative of e to the x is e to the x, and the derivative of minus 1 is just 0. So there you go. First times the derivative of the second, plus the second, just as it is, e to the x minus 1, times the derivative of the first, which is 2x. Yeah, and they combined everything, those pieces of poo-poops. Now look, if this is a short answer problem, completely acceptable. Don't try and combine it. Don't make a simple mistake combining it. But multiple choice, even though they don't tell you to simplify, the answers will be simplified. So we're going to have to do this. When I multiply these two, I just get x squared e to the x. Plus, I got to distribute my 2x here. So 2x e to the x minus 2x. All right, looks like that is 3 terms. It ends with negative 2x. Yeah. C. Number 6, she is C. All right. All these problems, 1 through 6, have been fairly quick. 7's going to take some time, and you'll see why in a moment. A particle moves along the x-axis so that at any time t, where t is greater than or equal to 0, its acceleration, okay, its acceleration is, and I'm going to start highlighting some of these important things. A of t, which is negative 4 sine of 2t. If the velocity of the particle at time 0 is 7, so a v of 0 is 7, and its position at time 0 is 0, then its position at time t is x of t equals. You need to come up with, they are asking you for an equation in terms of t. All right, here we go. Ready? First thing you have to absolutely understand is we are given acceleration. So we have position. In this case, position is x of t. We have velocity, and we have acceleration. All right? If I go this way, that is always one derivative away. We'll put d for derivative. But when I go back, I need to integrate, okay? Because I start with this, not taking the derivative. Then once I have velocity, I got to go back and integrate again. So I'm not doing derivative at all. So I've got to integrate once to get velocity. And then once I get that equation, I have to integrate it again to get position. Okay, so we're doing 2 integrations here, and there's trigonometry involved, and there's initial conditions so that I can get rid of my c when I integrate. All right, let's begin. In order to get velocity, we need to integrate acceleration. So let's integrate my acceleration, which is negative 4. That's a constant. I'm just going to pull that out here. Sine of 2t dt. All right. So negative 4 will stay out there. U sub. I mean, yeah. I can do it without u subbing, but let me show you guys. We should really do this so that everybody who doesn't understand it can get it. If u equals 2t, then du is going to equal 2 dt. But I only have a dt here. This is going to become u. Okay? So I'm going to integrate the sine of u. And I got to get rid of that 2 because I only have dt. So I'm going to multiply both sides by a half. So dt is 1/2 du. So the du comes down. The 1/2 I put on the outside. And oh, by the way, I also have a negative 4 out here that I got to multiply by. So this will combine to be negative 2. I take the derivative of negative cosine of u, and that would give me a positive sign. And since there are no bounds, it's plus c. So let's clean this up. A negative times a negative is a positive. Cosine. What was u? U was 2t, so I'm going to put that back in. That is my velocity. So how do I get an answer for c? I've got to use my initial condition that they gave me for velocity. At time 0, velocity is 7. At time 0, velocity is 7. So velocity is 7, okay, at time 0. And that's going to help me find my c. What's the cosine of 0? Oh my goodness. The cosine of 0 is Okay, here's 1, -1, and 0. We got 0. All right, and it's the cup. It comes up like this, down like this, comes up like this. So right at time 0, it's 1. Okay, so this right here is going to be 1 times 2, okay, plus c equals 7. 7 equals 2 plus c, so c is 5. So when I figured out velocity, this c is going to be 5. There you go. But I'm not done. I got to do the same thing again to come up with position because they're asking me about position. All right, so I'm going to scroll up a little bit. So now I have velocity, but I need position. So I'm going to have to integrate velocity to get position. So let's integrate, all right, this right here, this equation right here, because that's my velocity. 2 cosine of 2t plus 5. Let's not forget our dt. This is a constant. I'm going to move it out here. We just did a u sub right here, where my u is 2t, and my du would be 1/2 du to get dt. All right, so I'm going to do the same thing. If u is 2t, then 1/2 du is dt. Okay, I'm not going to redo the algebra because I literally did it right here. Okay, so I've got 2. The integration of the cosine, this becomes a u, plus 5. This becomes 1/2 du. My du is here. My 1/2, boom, on the outside. And I multiply. Okay? Half of 2 is 1. 1 times. The integration of cosine is sine of u. The integration of 5 is 5x plus c. I need a constant because there are no bounds. Okay? 1 times anything is itself. So I'm just going to get rid of this. This is position. All right? But they want an exact equation. Okay? First thing I'm going to do is I've got to substitute back in for my u. Well, u is 2t. So it's the sine of 2t plus 5x plus c equals position. And now I need an initial condition to solve that. Oh my goodness. I tried to do it so it didn't flip up. When position, okay, the position at time 0 is 0. Okay, so the position at time 0 okay, I don't know, this should have been a t. Let's be consistent. We're using the t variable, that should be a t. Otherwise, it makes it look like we have so many different variables here. Again, at time 0 is 0. Okay? Time 0 gives us a 0. The sine of 0. So what is the sine of 0? Let's go back to our graph. Sine is the s. It starts here, comes up, up, back down, whatever. And I know that at position 0, my sine of 0 is 0. 0 plus 5 times 0 is 0, plus c is 0. Well, that means c is 0. Okay, so right here in this equation, I'm going to make that c a 0. Whew, goodness. So I've got sine of 2t plus 5t. I could say plus 0, but I don't have to, equals x of t. That is the equation of position. I told you that was going to take a while, okay? And it did. If I scroll back up here, that's choice A. My goodness, that was a lot of work for one of the beginning multiple choice questions, okay? But it was a lot of easy work. Okay? You just got to understand, I'm looking at this board. It looks like a mess, but we got the answer done. 8. The graph of f double prime, the second derivative of the function f, is shown above. Which of the following could be the graph of f? Ew. Oh, Lord. Normally they only go one derivative away, but this time they're going two derivatives away. But that's okay. Instead of looking at slope, we're going to look at concavity. Meaning, I'm going to draw a graph right here of what f might be, could be. All right? All I know is that the second derivative is the y value. And I know second derivative is concavity, right? Is concavity of f. Concavity means it's either a happy face if it's positive value or a sad face if it's a negative value. So anytime the y, which is the same thing as f prime, is positive, my f should be smiling or concave up. And anytime y is negative, my f should be a sad face or concave down. All right, here's all the y values are positive when it's above the x-axis. Positive, 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 positive. All my y values are negative when it's below the x-axis. That means my original graph at this point will be happy. My graph here will be sad. That's a sad face. And then it continues to be happy again. So it's going to look like almost like this W. Right here, where it changes. So it changes right here and here. It's going to be happy. Then it's going to be happy again on the outside. And in between, it's going to be sad. So it should look something like this. I'm going to look here for that little W. Oh, bam. There it is. Pretty simple. Okay. 9 says, when x equals 2e, find the limit as h approaches 0 of ln of x plus h minus ln of x all over h. You should immediately realize that this is the definition of a derivative. Okay? This right here. They use the limit as h goes to 0. It's the definition of a derivative before we learned our power rule, our product rule, and everything. And what should stand out even more is, anytime you use this, the original equation is right here. And all that tells you is, I'm just taking the derivative of this at a point where x is 2e. So what's the derivative of the ln of x? It's 1 over x at an x value of 2e. So let's just put 2e in for x. Boom. A. That is really, really easy. So before we put in our function, in case you didn't pick this up, this is what the definition of a derivative looks like using limits. Notice the original function is always right here, always subtracting the original function. So that tells me, unless they specifically say I have to use the definition, that just tells me I'm really just taking the derivative of whatever's here. And in that case, it's the ln of x. Okay, we are on to the 10th and final problem for this video. And it says, if dy dx, or the first derivative of y, is x to the fourth minus 2x cubed plus 3x minus 1, then the third derivative of y, okay, d3y over dx3, evaluated at x equal to is, first thing we need is the third derivative. Don't take 3 derivatives of this because they've already given us the first derivative. So in order to get the second derivative, I take the derivative here. Okay, it's 4x cubed minus derivative here, 6x squared plus The derivative of here is 3. The derivative of 1 is 0, goes bye-bye. Okay? I only need to take the derivative one more time. Okay? So I'm not taking 3 derivatives. I'm only taking 2 because I already have the first one. I just found the second one. Now I take the derivative again to get the third. Okay? My third derivative, which is d3y over dx3, is derivative of that bad boy is 12x squared minus the derivative of that is 12x. Derivative of 3 is 0. All right? So now we want this at x equals 2. All right? So 12 times 2 squared minus 12 times 2, that is 4. 2 squared is 4. 12 times 4 is 48. Minus 12 times 2 is 24. Perfect. And in the math community, we lovingly refer to that as 24. And so my answer is B. We are done. And I tell you what, that problem 7 was pretty brutal for a multiple choice problem. We just had to do integration twice with 2 initial values. But besides that, this wasn't all that bad. Okay? Thanks for sticking around. Like the video, follow me so you get notifications, and I will see you for the second video, which will be problems 11 through problems 20. Take care.
Don't forget to subscribe and ring that bell.